Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. We're going to start into section 1.7 dealing with combinations of functions here. I know this is one of the topics that I think you usually look at towards the end of the year in Algebra 2. But the first part of the function, or the first part of the section, excuse me, we're going to look more at the arithmetic combinations of functions. So, we're just going to use two random functions for a lot of our examples. F of x equals 2x minus 3, g of x equals x squared minus 1. One of the things that really shows up differently in this section, it's just kind of a matter of the way things are notated. This is f plus g of x. It does not have anything to do with multiplication. So when you see this, again, it's just f plus g of x, meaning add each function together. So even though I realize for the addition we don't necessarily need parentheses, I am going to do that just to differentiate the two. And then you combine like terms. So equals x squared plus 2x and minus 4. With these, when you're just adding or subtracting, don't worry about trying to factor. This doesn't. There won't be any end gain by factoring. You're not being asked to solve here. The difference, again, much like up here, this says f minus g of x. It's just like f of x minus g of x. So, again, this is f minus g of x. So again, this is saying take function g minus, take function f minus function g. Now, the reason, again, I actually like using the parentheses is it kind of helps you remember, yes, we do have to distribute the negative. So subtracting will start us with the negative x squared plus 2x, and then negative 3 minus negative 1 becomes addition, so that will be minus 2 again. That won't factor anyway, don't worry about trying. Here, this is f times g of x. So again, it's saying take function f and multiply it by function g. And here, basically, all you're going to end up doing is foiling things out. So that will be 2x cubed. Let's see here, minus 3x squared minus 2x plus 3. Again, don't factor. If you factor this out, you're just going to end up with what you started with here. So that, certainly saves you some unneeded work if you do that. And then the last one, the quotient or division, f divided by g of x is the same thing as saying take f of x over g of x. So here you just have f of x, 2x minus 3 over x squared minus 1. The only real issue here would be, yes, you could factor this if you wanted to. And then as we work forward, the main thing is, yes, unlike the sum, the difference, or the product, there are restrictions. X cannot equal positive and negative 1, and we'll even talk more about domains as we work further into this section. So, from here, again, a couple of new functions. F of x is 3x minus 2. G of x is x squared plus 4x minus 3. Find f plus g of x, then evaluate f plus g of negative 1. So from here, what we can do is first add the two functions. Which x squared, 7x, and minus 5. Now, for this next step, this is f plus g of negative 1. Well, all that is saying that we are going to do is plug negative 1 into what we just added. So when we do that, Negative 1 squared plus 7 times negative 1 minus 5. 1 minus 7 minus 5 is negative 11. So we are adding and then evaluating. Similar question here, example 2. Subtract the two functions, then evaluate for negative 2. So here, 2x minus 3 minus x squared plus 2x minus 3. So negative x squared. Oh, those actually cancel, which is kind of nice. And negative 3 minus negative 3 also cancel. So the difference of the two functions is just negative x squared. When we now evaluate, the two negatives do not cancel. You square it, then take the opposite. Negative 2 squared is 4. The opposite is negative 4. And one final example here. Now we're just kind of back to what we did on the other page. Find f times g of x. Well, x plus 5 times 3x, and then you're just distributing. So 3x squared plus 15x again. Stop there. Don't factor it back out to what you started with. So this one, you are just doing the arithmetic combination only. All right, the final couple of things that we're going to look at. Again, if we have two new functions, f of x equals the square root of x, g of x equals the square root of 4 minus x squared, find the domain of f divided by g of x. Well, we end up with square root of x over square root 4 minus x squared. You know, one of the things that you can do for this is certainly make this into just one radical function. And as far as this goes, we do need to factor the denominator. And we actually looked at this a while back. So we do have a square root. We also have restrictions in the denominator. X cannot equal 2. X can also not equal negative 2. And so from there, what we end up with is, and here's where, you know, if you remember, I kind of like using our number line. Well, we've already said x can't equal either of those two values. If we plug in some numbers, you know, use 0, use 3, use negative 3, and then we can look at, okay, where is the function either true or false? Well, if we put 0 in, you have 2 times 2, which is, 4, and then a 0 there. Well, anything that you put in there, since you can take the square root of 0, that is true. Anything from negative 2 to 2 will work. Again, we can just verify. If you plug 3 in, you end up with negative 1 and 5. Well, the problem is, again, you have a square root under a negative, so that won't work. If you plug in negative 3, you end up with, let's see here, negative 3 over 5 times negative 1. Well, here's one thing that does work a little differently. So again, if I use negative 3, I have negative 3 over negative 5. Well, that actually becomes positive. So that is true. So our domain will actually end up being negative infinity to negative 2 and negative 2 to 2. So that one works a little differently there. So that because you have that value on the top, that does change things a little bit. So if we flip it around to where we have 4 minus x squared over square root of x, again, you can certainly do that. Well, the only thing that's going to change is if we factor, you're still going to have the 2 minus x, the 2 plus x. Well, when these numbers are now in the numerator, 2 minus x, 2 plus x over x, well, the difference now is our restriction, x cannot be 0. So that's the one big change for this one here. When you have a 0 in the numerator, it's not a problem. So from there, now what we can do is use 0, and if you use anything, certainly, although we do still have to worry about both 2 and -2, because if we were to plug in 1, well, you have a positive, and a positive, so that works. But what you do have to worry about is if we use something that is larger than 2. Well, if we use something larger than 2, you still have that same issue where you have a negative, a positive, and a positive. So if we use 1, you get a true statement. Although now we can have a closed dot, because at 2 it's just 0. So here this is false. Now at -2 we can certainly talk about, but also if we use -1, we now have so that's the one thing that does change a little bit. If we use a number between 0 and -2, like -1, you now have a positive over a square root of a negative. So that won't work. If we use something like -3, you end up with a positive, a negative over a negative. Well, if you have a negative over a negative, that does actually go back to a positive. So here your domain is -infinity to -2 with a bracket, because again now we have a closed dot, union 0 to 2. Again, our restriction, x cannot equal 0, and it's going to stop at +2. So changes things a little bit when you flip. So that completes the first half of section 1.7.